The last section of Chapter 1, Section 7 is evaluating and rewriting expressions. If you remember, expressions are just statements without an equal sign. So we're going to rewrite those. We're going to start by evaluating them. To evaluate is to give a value to. And a lot of times we have letters in here. We've got variables that don't have a value. So in order to evaluate an expression, we want to replace the variable with a number. So we're going to take a number and put it in for the letter and then simply work the problem. So our first example here is 4m minus 3 times the quantity n minus 4. And this is our expression. There is no equal sign. I'm giving you m equals 3 and n equals 2. So if you think you know how to do it, pause it and do it, and then come back and make sure you got it right. So you're going to plug in 3 is m. That's a puzzle piece. So you just plug it in. So you're going to have 4 times 3 minus 3 times the quantity of n, which is 2, minus 4. And then simply use your order of operations to solve this. So your 2 minus 4 is a negative 2. So you have 4 times 3 minus 3 times a negative 2. So we did our parentheses. Now you do multiplication and division left to right. 4 times 3 is 12. Negative 3 times negative 2 is positive 6. So 12 plus 6 is 18. That's your value. You're finished. Let's move to the next one. Pause it, work it, and then make sure you got it right. Did you pause it? Here we go. 5r squared divided by d minus 3. Here's our r puzzle piece. It's 2. And our d puzzle piece is negative 5. So just fill them in. So 5 times r is 2. We're going to square that. We're going to divide by negative 5 minus 3. So our exponents first, 2 squared is 4, so 5 times 4 divided by negative 5 minus 3. 5 times 4 is 20. Negative 5 minus 3 is negative 8 because the signs are the same. We add and keep that sign. And so now our final answer is going to be negative because we have a positive divided by a negative. So we've got a negative, and this, you can't take 20 divided by 8, so we're simply going to reduce it down. So what you're going to do is kind of say, 20 is 4 times 5 is 20, and 8 is 4 times 2. So the 4's will reduce and leave you just with 5 over 2. And it is okay to have a fraction as an answer. It's okay to have an improper fraction. Just leave it, just like that, negative 5 over 2. So that is evaluating. There are several on page 71 that you can try on your own. What would have happened if, in this problem, what if our d value had been 3? If our d value had been 3, let's say d was 3, then we would have ended up with 3 minus 3 in our denominator. And can we take 3 minus 3 is 0? Can we divide anything by 0? And hopefully you hollered, absolutely not. Anything divided by 0 is just not possible. It's undefined. So there are times when we need to know what values for our denominator are just not possible. And so what we're going to do is we're going to set, if our denominator is ever 0, then that is a value for our variable that cannot be true at all. All right? So what we're going to do is this. Let me give you a problem. 2m over m minus 3 and m plus 4. So the problems will say, find where the denominator, find what values for your variable will make this statement undefined. So what you're going to do is you want to find out, where is this denominator equal to 0? Well, if you have two numbers multiplied together, if either one of those equals 0, then when you multiply them together, your answer is 0. So you want to find out, where is this value equal to 0? And where is this value equal to 0? And neither of those are possible solutions for this equation, for this expression. So you'll set m minus 3 equal to 0, because that's going to be a non-solution, and m plus 4 equal to 0. If either of these is true, then my answer is undefined. So you're just going to solve for that. Add 3 on both sides. So m equals 3. Subtract 4. M equals negative 4. So if either of these is, once we're solving, if either of these is our solution, then we know it's not actually a real solution, because we're going to end up with an undefined answer. So the problem will say, determine the value that can cause expression to be undefined. So what you're going to do is set each product or each factor equal to 0 and solve. And those are your answers. At 3 and at negative 4 is where this expression is undefined and there is no answer. All right, moving along. I tell you what, when we do it this way, we go a lot faster. The next thing we're going to discuss is when we're evaluating and rewriting expressions, we may want to use the distributive property, which hopefully you already remember. The distributive property simply says that I wrote the wrong number. That's not really what the distributive property says. That's what I say when I make a mistake. All right. The order of operations says to add this first. So if we take 2 and then add 5 plus 6, we get 11. 2 times 11 is 22. But the distributive property says I can multiply first as long as I multiply everything on the outside by everything on the inside. So 2 times 5 is 10. 2 times 6 is 12. And 10 plus 12 is 22, which is the same as I got when I added first. So the distributive property simply, so this is the distributive property. It simply says you can add first or you can multiply first as long as you multiply everything in your parentheses. All right. You need to remember that that doesn't work for adding. You know that, right? Or for adding on the outside. Okay. So I want you to distribute this one. Do this one on your own and then come back. Be careful. I tricked you with a negative. Don't let me mess you up. All right, did you come back? Here we go. So we're going to distribute through. So a negative 6n, and then a negative times a negative is a positive. 6 times 9 is 54. So a negative 6n plus 54 is your answer. This is why this is helpful, because if you've got just numbers, then it's a lot easier just to add them together. But if you have a variable, you can't add n and a negative 9 because you don't know what n is. So this is where your distributive property comes in handy. You can multiply that through and divide that out, because the next thing we want to do is we want to simplify, and so we want to combine like terms. If you'll remember, terms are simply the add-ins of an expression. They're the parts that you add. So those are the add-ins. They're the add-ins of the expression. The coefficient, you need to know that that is the number in front of the variable. You need to know these terms. Write them down in your notes so that you've got them. And like terms are parts that have exactly the same variable with the same exponent. Same variable, same exponent. All right, So when we're combining like terms, we need to make sure that the terms are actually alike. And once you have like terms, then you just add the coefficients. And I think that you've done this before, but let's do some just to make sure. Let's look. So something like this, 7x minus 2x. So if I have 7x minus 2x, the x is my variable. The 7 and the 2 are my coefficients. Because these x's are the same, I can combine these two simply by saying, well, there's 7 x's here, and there's negative 2 here. So 7 and negative 2 is just 5. So we have 5x when we combine them. All right. What that looks like is you've got 7 little x's here, and you're taking 2 little x's away. It's almost like going back to first grade where you have 7 x's, and now I'm subtracting 2 x's off. I have 5 x's left. All right, if that helps. All right, what if I give you something a little bit more complex? 4y squared plus 5 plus 3y squared minus 9. If you think you know how to do it, then pause it and do it and come back. Because what we're going to do is we can only combine like terms. So we're looking for the things that are alike. I see y squared here and I see y squared here. So I can put those together. And I see a constant and a constant. So I can put those together here. And if you can see those, you don't have to write this step down, but if this step helps you, then go right ahead and do that, all right? Because now I can combine, I've got 4 and 3 of them, so together that's 7y squared. And this is now, be careful that your signs stay with your term. When you're moving these numbers around, you can move them as long as your sign stays with the correct term. So you've got a positive 5 and a negative 9, so minus 4. And because these are not like terms, you can't combine them together, you're finished. That's as far as you can go when you're combining those like terms because there's nothing else alike. Let's do one more. Let's do a tricky one. 1/3 n minus 9m plus 2 minus m plus 1/4 n. Whoa! All right, and don't stop on me just because there's fractions. You can do this. All right. So what we're going to do is we're going to look for the like terms. And looky there, the fractions are going to go together because there's an n and an n. So let's put those together. 1/3 n plus 1/4 n. Those go together. Here's m's. Those are alike. Be careful. They both have negatives in front of them, so don't lose them. Negative 9m minus an m here, and here's our constant term. So we tag that on to the end, and it doesn't have another one, so that part is really already finished. So let's work from the back forward just because the fractions are scary, but we'll leave them last so that, oh, there's nothing left but those. We can do that. So the 2 is by itself. The negative 9m and a negative m, because they're both negative, you're going to combine them, but whoa, what happened? There's no coefficient in front of here. Don't forget, if there's not a number in front of that variable, it's the same as a 1. Don't forget that, okay? So if there is nothing there, if there's nothing in front, no coefficient, it means there's 1, all right? So negative 9 and negative 1 is negative 10m. All right, now let's tackle these fractions. We can do this. So 1/3 and 1/4, don't forget when you're adding, because that's what we're doing here. We've got to combine these. We're simply going to add them together. We simply have to add, and you can do this over here on your scratch paper, 1/3 plus 1/4. And you're going to combine those together. Don't forget, you've got to get like denominators. So when we're looking to see, 3 is going to be 3, 6, 9, 12. 4 is 4, 4 times 2 is 8, 4 times 3 is, 12. There it is. We just have to multiply 4 times 3 this time. So 3 times 4 is 12, so you got to take your top number times 4. So you've got 4/12. 4 times 3 is 12, so you got to take your numerator times 3 because you took your denominator times 3, so you're going to add 3/12 to that. So now we have 4 plus 3 is 7/12. So we have 7/12 n minus 10m plus 2, and because those are all different terms now, we're finished. Even though it doesn't look finished because we haven't combined them all together, we can't, because an n and an m and a constant term are all different terms, so they can't be combined. All right? So here we go. Distributive property, combining like terms, evaluating, lots of steps, lots of things. You can do it. All right, I'll see you next time.